Hi, guys and ladies, welcome back to another exciting episode. My name is Disema Matsietsi, and this is episode number 12. We had great fun in episode number 11. If you missed out, don't worry, you can always go back and listen to episode number 11 where we spoke about the different type of data structures. So this episode, we are talking about ways to understanding machine learning and data science models. We're just doing a high level beginner's guide to say what is it, so that if you go around and you're hearing people talk about things, you mustn't get confused, so that you can also find out, is this for me or is it not for me? We'll start discussing that just after our theme song. Stay tuned. It's quite amazing how we live nowadays. The time that I'm recording this is 2023, and by now we can see a little bit of how data science and machine learning has actually revolutionized our lives around it. Most organizations are now talking about understanding their data much better. And that's where the need for the people that are specializing in data science and the people that are specializing in machine learning is now going into unprecedented record high. All of this, I knew immediately as soon as I stepped into when I was doing my honors degree, that, this is something else. And I was quite right. I don't see it slowing down anytime soon. I see it still growing for the next 10 years. So if you're thinking about becoming an analyst or thinking about specializing in machine learning or data science, I don't think it will be a bad move, because it's still going to be on the rise for the coming years. What I'm anticipating and what I'm hoping for is more people going in, so that we can able to not just serve big organizations, but also leave enough workforces to actually serve the small fields. Before we go on, I'm just going to do two things that I'm going to split out. First, we're going to explain what is machine learning, looking at the different types of machine learning. And on the other side, I'm going to be discussing different models of data science. And in this way, we're going to try to put them together so that we can know more or less how does it go. So machine learning is normally what nowadays we call it as AI. So artificial intelligence. This is where the machine goes and start learning the same way as you and I do. There's a lot of things that we do intuitively, but there's a term for that when it comes to teaching a computer to do stuff the same way that we do it. So I'm going to try to use real life examples to make you understand what does it mean to, start letting the computers learn, or starting the computers, be more like making human decisions. So there's two types of machine learning. The first one is called supervised machine learning, and the second one is called unsupervised machine learning. So when you're talking about the supervised machine learning, you're talking about machine learning that involves training using a labeled data, where each data point is associated with an outcome or a target. So each data point, it says this is what the outcome should be, or this is what the target should be. It's more like, growing a baby, looking after a growing baby. You always want to give them milestones, and you want to push them towards those milestones. So each data point, it's either, going into a certain output, or but the output is already known. So we're saying we want to teach this computer to tell us this truth. So the computer will go around, go around. If it gets something wrong, we keep on clapping it. That's why I say it's like teaching a baby, because as the baby is crawling and they're crawling behind me, I'll say, no, that's not where you crawl. Next to the electrical cables, you crawl this side, you crawl that side. You already have a, a data point that you want. That's why it's called supervised learning. And in order to do this, there are different ways of doing supervised learning. But now I'm going to be looking at two ways of doing it. First one is by making use of something called regression, which is supervised learning technique used for predicting continuous numeric output or values. So for instance, you have a yearly or a monthly update on probably sales. So we can tell this thing to say, okay, um, the the sales are going in this way. You got one, you got two, you got three, you got four, you got one, you got two, you got three, you got four. So you already have the target. So with using regression, you can actually push your computer towards the outcome that you want. Um, and this could be achieved by analyzing the relationship between inputs, features, and a continuous target variable. Regression models can estimate values such as housing prices, stock prices, or sales figures. Because we already know what's going to happen, regression can help us to estimate what will be the house price if you don't buy it today. What will it be in 10 years time? The higher the regression number tells us, the how close it is with all the other variables. So your regression will always have, say for instance, you have 7 variables. You want to use those variables in determining what the future stock price will look like. The higher the regression value, the stronger is your confidence towards you getting those numbers that is telling you about. The lower the regression values, the lower the confidence. Say for instance, you want to determine the house prices, but you are looking at data about how a plant grows, another data about how groceries basket is growing. Because they are not related, you'll get a lower regression value. But if they are related, you're taking data about the economy, you're getting data about people's salaries, you're getting data about employment rate. When you put them together, the model will tell you, oh, hang on a second, it looks like these variables talk to each other, and then you will have a higher regression value. The second one that I'm looking at, we're still talking about supervised learning, is called classification. And classification is another supervised learning approach that deals with predicting discrete class labels. Predicting discrete class label. In this method, the model learns to identify patterns in input features and assign data points to predefined classes. So we already do this automatically as human beings. Already, when you watch this video based on my accent, based on my skin color and everything, you can already use a class to say, oh, I think this guy belongs to the African ethnicity, and you're already throwing me into that class. Oh, I think this person belongs into this whatever wealth category, or this person belongs into this. He might be loving this type of music, and you throw me into that class. We do it easily with our heads, and it's so easy to class people or class things. But with a machine, it has to learn, and we push it to say, okay, go in this way and class things according to. Classifications model are commonly used for tasks like spam detection and sentiment analysis and disease diagnosis. I always look at that spam detection to say, imagine if your email didn't have spam detection, all the emails that are coming through were just gonna go into your face. But now it goes and it classes to say, hang on a second, this email doesn't look like it was um, created with intent for this person. So it just push it on the other side and say, this looks like a spam, this looks like a Trojan horse, this looks like whatever. So all of that is called supervised learning, and it's under classification. Let's now move over under unsupervised learning. Unsupervised learning is where you are actually letting the computer find its own target. It's not like, just letting a naughty child go crazy, writing on the walls, calling it that unsupervised learning to say, let's just the kid play. In it won't be visually appealing to the child, and they'll stop, playing with the crayon on the walls. It is not like that. But in this case, we're letting it go around and discover things that we don't know about the data that we have. Hence why it's called unsupervised, because we don't have a target model, or we don't have an end state in mind, or we don't have the data currently to say we have 17 points, give us the 18th one. We don't have that target. We're just saying, okay, computer, show us what you can show us out of this data. And it comes back to say, oh, this is what I found out in that data. So the best way to do this, I'm also going to pick on two that are doing unsupervised learning. The first one is called clustering. So clustering, it might sound like classification after I explain it to you, but it's not. I assure you. Clustering is an unsupervised learning techniques that groups similar data points together based on their similarities or proximity in the input feature space. Like, say for instance, we have a person who stays in Johannesburg, and then we have all these other people that stay closer to Johannesburg, all the other cities that are closer to Johannesburg. When you look closer, you'll say they are staying far apart. But when you zoom out into the continent, you will see them together as, oh, hang on a second, those people are living in the Johannesburg area. If you go further, but if you come closer, they are far apart. But depending on what lens you're looking at, um, they can be together or not be together. So when you do a clustering on the computer finds out whatever level to say, out of whatever level, I can find 6 clusters, or if I go up, it's just one cluster. If I go all the way up, you know, it, all the data in the world just becomes a small speck. But as soon as you come closer, depending on what you're looking at, you have different clusters. You can say, oh, this one looks together, this one groups together, depending on different features that they have. So clustering algorithms that I normally used to use a lot is the k-means. We can also use the hierarchical clustering, and you can use that one, when it comes to the consumer segmentation, image segmentation. Apparently they use that, and other anomaly detection. I know with customer segmentation, we totally want to use those clustering so that you can tell us to say a person who, more especially in banking, a person who has this pattern of debt or lending behaviors, they can belong into this cluster or not. We normally do that one easily on a high level to say, oh, I think we're gonna take myself and whoever and put us together as a cluster, but here a computer is doing that thing based on the data. So just because we look the same, we might not be in the same cluster. Computer will find attributes that are similar to both of us and put us into the same cluster. So when you have too many variables, it will be able to group them together to say this one is team 1, this one is team B, this is the other team. If you're looking for problem children in your data, it will tell you to say these are the top performers, these are the bottom performers, and then you can actually start looking at the bottom performance. A nice part about it, because it's unsupervised learning, as soon as somebody else start performing quite well, they go up under the good performance, and then you start managing this book that is pre-delinquent or the delinquent ones on their own based on clustering. Okay, the second one is called variable reduction. As it is, take for instance myself, there's so many variables that you can use to describe me. First could be my accent, my skin color. Another one is maybe I'm wearing glasses or I don't wear glasses. My hair color, we can go on. Nails, are they long or short? What t-shirt am I wearing? What pants am I wearing? What shoes am I wearing? You can use all those variables to describe me. But what happens with variable reduction is it takes all those variables and it says, okay, out of all those variables, which ones are much more significant in describing me? So for instance, if it says, okay, if all of myself and you, we are standing next to each other and we're wearing the same clothes, Then it says, oh, hang on a second, is it important for me to use shoes as a determining factor? It picks up that both of us are wearing the same shoe, it cancels out shoes. T-shirts, we wear the same t-shirt, it cancels out our t-shirts. Then it goes to ethnicity. Then it says, oh, you are non-black and I am black. Maybe we can use ethnicity as a way to describe me. So when it comes here, it will say, oh, the black African guy. If we are sitting with Asian people, European people, and Indian peoples all together. So it will use that to explain, to to explain me as a person. So in the whole process, what it has done is it has eliminated all the other variables that were contributing very little to my description, which is the shoe type, the t-shirt type. They don't weigh. So we had that many variable. We just reduced them to the most significant variable depending on the data that you're working on. So I think I'm trying to analyze that one. It's also known as the dimensionality reduction, and it aims to reduce the number of input features while preserving important information. Techniques like principal component analysis, or PCA, or feature selection methods help in identifying the most relevant features, simplifying the data, and improving the model performance. So only the thing that matters the most is the one that we do look at. So you might have 200 or 300 variables. It might come back to say, I'm only going to use 5 variables. When I was doing my dissertation, we even got into a point where it was creating new variables for us, to say, hang on a second, for me to work on another model, which is the second step. The first step was to say, I'm taking 200 variables, for instance. I'm going to create only 5 variables for PCA. This will be the one that I want to explain using the 4 variables. So one variable will be the dependent one, because I want to explain it, and the 4 out of the 5 will be the independent one, because they explain the movement in this variable. So if the movement is highly the same, if this one goes up and the 4 goes up, it's highly correlated, and the other way around. But all of that 5 variables that I come up with are derived from 200 variables that were explaining me, for instance. So we've done principal component analysis. We've just reduced it into a smaller thing that we can handle and understand it ourselves. So that's machine learning. So there are other types of machine learnings that we can talk about. So this one's, when you talk about the other types of machine learning, in my head, for me to really remember this, I think of it as, syllabuses, like syllabuses that we go through in order to understand things. For me, you would have, different ways of how the machine is doing its learning. It's like when you have the national syllabus, I think it's called the CAPS, and then you have the one that's done by the private schools here in South Africa, I think it's called the IEB, and another one that's done by another type of private school called the Cambridge Education. So you have different syllabuses. So in machine learning, we have more or less the same thing. Not all machine learning is the same. The first one is called reinforcement learning, and the second one is called neural network or deep learning. So whenever you talk about deep learning or deep AI, I'm just going to explain it a little bit so that you can understand. But first, let's just start explaining reinforcement learning. So reinforcement learning focuses on training an agent to make sequential decisions in an environment to maximize a cumulative reward. It's like teaching your dog that when you do this behavior, you will get good rewards. If you do this behavior, you get bad rewards. If it relieves itself inside the house, you clap it. If it relieves itself outside in a dedicated potty area, you give it a treat. So that's what reinforcement learning does. It's like a maze. It finds hidden coins as the machine is going around learning, to say, we want you to learn positive words. and not swearing words. So out of the pool of words that everybody's talking about and are being thrown, once it makes sentences out of vulgar words, we punishes it. But when it makes sentences out of maybe good words that makes us happy, then we give it rewards. And then it becomes it. We just keep on reinforcing it that way. Likewise, reinforcement learning is where the agent interact with the environment. It receives feedback in the form of rewards or penalties and learns optimal strategies. This type of learning is used in robotics, in game playing, and autonomous systems. We we all aim to have the desired behavior that we want, and we want to punish for the ones that we don't want. Same is in a game. In a game, you always want to, because you know the pathway. You can take as many ways as you want, but we want you to go through that pathway. When you go the other pathway, then you die. You have to repeat the stage again. So we just tell it to say, do whatever you want to do, but the actual pathway that we want the person to go through is this one. But you have infinite possibilities that you can do, but you only get a reward if you do that nice pathway. Same is with on robotics also. They use what we call reinforcement learning so that the computer can know what to do. The second one, which is the neural network and deep learning type of analysis, is where the neural networks are inspired by the structure and the function of our human brain. So deep learning, a subfield of machine learning, utilizes neural networks with multiple layers. This approach has gained significant attention due to its remarkable success in image recognition, natural language processing, and speech synthesis tasks. So if you're asking yourself, what is ChatGPT and all of that fast? It's because of this thing called deep learning. I was quite even impressed with my video editor because it goes into detail and it can identify my voice and can be able to create transcripts based on my voice. Other ones before, they used to get it wrong, but I think with chat gpt or GPT-4 being so well to understand human language and human input, things have actually becoming much better. They can even identify different accents based on South African accent, Black South African accent, Afrikaner South African accent, Indian South African accent, all of those different accents. It can even pinpoint to say, oh, this person, based on how they speak, it must be the mixed race South African person. That's just how good we've given these things data for them to actually grow and identify us. That's just machine learning. So we spoke about the type of machine learning, supervised, unsupervised, and we've spoken about the models or ways, syllabuses of machine learning, which is reinforcement or deep learning. We're going to move over to another one where we're looking at data science models. Data science models, I must say, if you understand machine learning, you will get why it's important for us to understand machine learning, especially when you're doing data science. So for our discussion, I'm going to be talking about three things. First one is the Monte Carlo simulation. Second one is called the rule-based modeling. And the last one is, other statistical models. I'm just going to put them all together. I'm not going to break them down into different, components by themselves. Otherwise, we're going to have a long podcast. So the first one, which is the Monte Carlo simulation, we use this, I think, when we're doing project finance. It's where it helps you with scenario analysis. So you have your inputs, which is your scenario. Economy goes down, people don't buy houses, people buy cars, whatever the case is. You have your scenario pace, and you can plug in whatever you want to put in as a variable or whatever the thing that you want to put in. Number of houses sold, it's going to be 200,000. Number of cars sold, 5 million. You put all of those variables. And what the Monte Carlo simulation is, it will give you exactly in real time to say, what is the high, medium, whatever the case, scenario plane, to say what will happen in the future. So I don't want to call it forecasting, hence why I call it scenario planning, because forecasting is we take the history and then we predict the future. That's what regression is. But scenario planning, we learn from the past, and then now let me play with different scenarios, and then once I get the different scenario, then it will tell me which path is it gonna go. It's gonna be high road, low road, medium road, whatever the case is. And then we take that snapshot is the one that you're submitting. This is quite important when you're doing strategic management or strategic planning. Monte Carlo simulation is the best one that you can go with, because you just say right there live in front of everybody, if the variables change, we would all see, okay, put that into this number of unsecured lending being bought, and move on. Second one that you going about is the rule-based model. So rule-based model is also known as an expert system, utilizes predefined rules or logical statements to make decisions or solve problems. This model encodes human expertise or domain knowledge to reason and infer outcomes. So rule-based are employed in stuff like medical diagnosis, fault detection, and recommendation systems. So if when we're recommending something, it's this type of machine learning data science model that we can say, oh, we're going to create a recommendation system, so that when we see the type of shows that you're looking at, we can recommend another show that you might like. I know you're thinking about, the likes of streaming services, Netflix, Apple, you name them. They are using the rule-based modeling to recommend for you the next show that you might want to look at. Okay, so I'm throwing everything else, all the other statistical models in here. That's where you're looking at linear regression, logistic regression, time series analysis, Bayesian modeling, and all those other things that are quite fun. Reason why I'm calling them all other statistical models, I feel like the other ones are quite, stand out a bit on data science. These other ones, you can still find them in stats. So all the other stats things, you put them in here. Learning R and Python could actually, give you the best. You can be at the top of the best if for all of this other statistical model. So that's it, ladies and guys and ladies. I hope you quite enjoyed this podcast. It was just a high level view of what it looks like in machine learning and in data science, just looking at all those different models that are being employed into data science and all those nice things that's been happening on machine learning. So this was episode number 12. I hope to see you again and join me again on episode number 30. So stay tuned. We'll chat on the next episode.